Hey, I am Nick Khami. I currently work at Mintlify, where we help companies build developer documentation websites. And we've been using Unleash for almost a year now, having quite a bit of success. It's a pleasure to be here today to talk about how we use the product and how we do feature ops as a whole at the engineering org. I'm excited to go into it with everyone here present on the call today. At the end, I'll open it up for a few minutes of questions as well. So we went ahead and adopted Unleash in October 2025. Catherine, one of our engineers in the team, had previously used Unleash at Pitch and vouched for us giving it a shot. And that's how most good tooling decisions happen. Someone on the team who we trust or who everyone trusts has lived with it and used it before, or has had a friend live with it and use it before. The best decisions and the best marketing is almost always word of mouth when it comes to developer products. Our goal was to get a control plane that we could automate against instead of a more seat priced dashboard. We wanted something that was API first, had open source roots, and pricing that made sense at our size. But adoption started the way it always does. We had a handful of release flags, 4 or 5 a month, treated as exceptions for risky changes. For context, we had about 30 engineers, which is a pretty small team, but there are 40 million total humans who visit a Mintlify site every month. So the blast radius of us making mistakes is always very large. And the final important thing here to note is that in October, when we began using Unleash, it was all on the front end. It took us a much longer time to adopt it on the back end, which ended up being really, really important. And to explain the importance, I want to talk about a major incident that we ended up having in May, which we could have avoided with Unleash on the back end. So on May 20th, at 12:38 in the morning Pacific time, my phone went off with a P0 incident. We use MongoDB for our database, and every replica we had was down. That meant that search, the dashboard, our what you see is what you get editor, our docs update pipeline, all of our AI features, everything was down. It was an absolute mess. The especially funny thing is that this happened the day before the first time I was going to do a draft recording of this presentation. So it really sticks out in my mind as a unleashed specific moment. And I want to tell you about that night in more detail because a lot of what I believe about feature ops has come from that specific incident. The cause was kind of funny. We have a part of the product, which is a little bit of a marketing dashboard. And on that marketing page, there's a leaderboard of how agent ready a bunch of very popular documentation sites are. Someone was refreshing that leaderboard a lot for some reason, or someone was scraping it. And every time the page loaded, it enqueued a refresh job for every site that was on the page. So each one of those jobs ran an aggregation query across everything that we track. If you've used Mongo in the past, you know that aggregation queries against Mongo are not ideal. They put a lot of load on that database. So as someone continued to refresh that leaderboard page over and over again, it requeued more and more jobs. We ended up with tens of thousands of jobs, and each one of those jobs was queuing up several aggregation queries. I think at peak, we had 32,000 plus aggregation queries in flight at the same time, which meant that every single replica of MongoDB that we had tipped over. At 1:45 in the morning, we were back up. We marked it resolved, and at 2 a.m., it went down again. So in total, we had about 3 hours of total outage overnight for a platform serving in that period, I don't know, millions of developers. The actual front facing websites were still up, but the back end experience for everyone trying to update their documentation site or use search or the AI assistant on a given page was not available. So, how did we recover this at the time? Whenever this occurred, we found a code fix to remove the aggregation queries from the leaderboard refresh jobs. We put up a pull request for that, or well, Claude put up a pull request for that. We force merged it at 2 a.m. in the morning, really no manual review, YOLO. I was in the AWS console, manually restarting containers with ClickOps, trying to make sure that everything rolled over as fast as possible. In parallel, one of my teammates also came online to help with the incident, and they were emergency scaling the database cluster because even after we got the server fix out, we would not have been able to restore service until the database cluster refreshed. The part that hurt a lot is that every job queued during the outage came back stuck. And some of the jobs which were not oriented to that leaderboard were legitimate, like all of our customer updates. So trying to figure out exactly which customers were affected with a legitimate job getting stuck was a massive pain the next morning. Um, and at the same time as I was dealing with that, or my teammates were dealing with that, I had my first call scheduled with the Unleash team about this talk. I recall that I had to cancel it like last minute because I was up all night dealing with the incident. So this particular incident feels extremely fated. Uh, and I think it has given me a real personal connection to future operations. And a lot of what we experienced there could have been avoided had we feature flagged more of those leaderboard queuing jobs on the back end, so we could have instantly turned it off without having to wait to force merge a pull request and then click ops in the AWS console to scale our database cluster. The important thing to note here is that with AI, especially now, we can write and ship code incredibly fast, but we can't stop anything without feature operations. Our only controls the night of that incident were git push and the AWS console. Deploys were our release mechanism, rollback mechanism, and incident response. All the same lever. It is slow and it overloads what is the ideal state. And this is the real case for practicing feature ops. We are able to use feature ops in the future to roll back and respond to incidents much, much more quickly than we ever could by waiting for a git push and redeploy. I've created this diagram here to explain that. If you look at what you're seeing on the screen, you can see the difference between what we had set up for our front end with Unleash versus what we had set up for our back end. With the front end, if we shipped a new feature, we put it behind a flag, and then if something went wrong with that feature in production, it only took a few seconds to flip that flag off. Whereas on the back end, where we don't have a flag, there was no way to instantly revert a change or turn off a feature that wasn't working. Had we been using Unleash on the back end as well as the front end in May, then we would have been able to instantly stop and prevent this incident. Once this is something that we became aware of and realized, we started practicing feature ops across not just our front end features, but our back end as well. The way that we coordinate and queue jobs, the API route improvements that we make, the different kinds of queries that are available through the API. A lot of features now on the back end are also behind flags. And once we made that change, about 7 months into using Unleash, we started to see our usage really pick up, which I thought was a good way to measure that the team was having success using the product more now. And I created a little chart where you can see that happening here. So in the total 8 months that we're seeing the screen, we've gotten about 84 flags active, and 25 of them have been archived. So we went from kind of like 4 to 5 flags a month to over 20 a month. And June is on pace to be our biggest month yet, which is exciting. This is not a tooling thing. We didn't just instantly adopt Unleash and start practicing really, really healthy feature ops. It took some effort with people on the team to communicate through how to practice feature ops and then start doing it. Um, and if you look at our GitHub, you can see the same story. The number of pull requests that we have, which are flag related, has gone from about 5 a month to 80 to 100, which is even more than you're seeing here because sometimes flags can have dual purposes. And the final set that I'm super proud of is that we have a team of about 25 engineers, and 18 of them have created flags. So we're seeing that every one of the teams participating in the process as an individual contributor, which I think is awesome. Because whenever you're practicing feature operations at any organization, you want to make sure that it's a team sport. And there's not just one or two people that are driving all the usage. Because if there are only one or two people on the team that are actually driving the usage, then you are not going to be set up for as much success as if it's everyone. It needs to be a unified effort. That way, no matter what you're shipping, no matter what part of the product it's in, you're able to control it via feature flags. Um, and the other thing I think is very, very important here is to use gradual rollouts. This is a tip that we've kind of learned over time when we're launching new features. Our goal is always to make sure that things aren't going to break. But given that we have so many customers who use the product in so many different ways, it's difficult to be 100% sure that something is good to go. We can only write or generate so many unit and integration tests. As a result of that, we've moved to a gradual percentage rollout release type, where over the course of several hours, we roll a feature out from 0% to 100% of the customer base. It is the exception that we have on and off feature flags instead of the rule. The general rule is try to use rollout instead. We also have different kinds of contexts for how our feature flags are constrained. So occasionally we want to do a rollout to people by customer segment. So we want to put all the free customers onto the feature, see if that goes well, then all the pro, then all the enterprise. Also, sometimes we want to do it by usage. So everyone that has used a part of the product in the past week, we want them to get access to the feature. And then people who are less active, we want to keep the product stable for them for a little bit longer, since it's less likely that they are going to care about the improvement. Um, Occasionally, we also just do this for the entire customer base as well, where it's kind of just based on organization IDs. To facilitate this and make it possible, we have started to we had to make more of that analytical data accessible from our OLTP database. So we use ClickHouse for analytical data and MongoDB for transactional. We've taken a lot of the materialized views that we have in ClickHouse for how features work, and we've put some of that data into Mongo so that we can use it for our constraint targeting. And I really recommend doing this. As you are adding feature flags or as people on your team are adding feature flags, try to make sure that during code review, you are checking to see if the constraint target makes sense for what the flag does. And finally, you have to practice good hygiene with archiving. If your flag count only goes up, then you don't actually have feature operations. You just have tech debt with the UI. Uh, and what you want to do is make sure that once things are fully stable and you are confident in them, you go ahead and remove and archive the flag. The reason to do this is just to keep things clean. That way you can track and see what's in flight and changing versus what has been fully rolled out and completed. We've had a bunch of success with archiving, and I think it's something that our team is practicing well now. The funniest one we've archived is our April Fool's flag. So of course, we didn't want to release our April Fool's, gimmick before April Fool's. We put it behind a flag. The minute it hit midnight Pacific time, we turned it on. A couple days later, we archived it. Uh, I'm very proud that our overall cleanup rate right now is 23%. And I think that's what you should be looking for. You want to see that over the period of a quarter, you're archiving at 5% of the feature flags that you create. Yeah, so 9 days after that incident in May, one of our engineers did end up shipping this flag. It's called pause update workflow queue. And uh, whenever it's flipped, the update pipeline for those leaderboard jobs pauses, either in the development environment or in prod. The jobs queue safely while it's paused, but they don't drain until it's flipped back. We built this for preventing a similar incident in the future. Basically, anytime one of the workers has a query which could negatively affect the database, we are able to instantly pause those workers consuming jobs. Um, and we now have 8 kill switches that look like this. We can pause updates, we can kill our caching layer, we can break circuits on how our billing logic functions if we start billing customers too much. And then we can skip specific parts of what the worker does, including indexing and syncing changes from the GitHub repository that our customer cites as content lives on. So the next time I'm up at 12 a.m. in the morning, it is just going to be a toggle that I have to flip instead of an all-nighter where I'm click opsing the AWS and the MongoDB Atlas dashboard. And I'm really proud of that. This feels like it is a lot of progress for our team and our engineering, product design, operational function. Um, Going into the future, we are going to start having more and more of these, and it gives me a lot of increased confidence that our product will be stable and controllable by our engineering team. Um, and now, kind of moving on from talking about feature operations in both the context of front end and back end, I also want to talk about how AI agents have impacted feature ops for our team. So, in the past year, AI agents like Claude Code and Codex have gone from producing a small amount of code to a large amount. We use it almost religiously across all the engineering function. I would say that the majority of our pull requests are being worked on with an engineer piloting some kind of AI coding agent or working in parity with them. We don't yet have a bunch of them running in the background in loops putting up pull requests, but writing software has stopped being the constraint. We have way more code per engineer per day getting merged. And what that means is each deploy, we deploy once a day at 11 a.m., carries more changes. So that deploy as release cadence started to break down for us, given that we were moving faster. And a lot of the question ended up being, yeah, we know that everyone on the team can put a ton more changes into every release, but is that a good thing? You know, the question to ask for our engineering product design is no longer can we build it? It's more who should we build this for? And is right now the right time? And a lot of that is a flag decision instead of a deploy decision. Just because we roll the code at 11 a.m. in the morning does not mean we want every change that was present in that release to roll out at 11 a.m. So to control that rollout, to be a little bit more progressive about it and make sure that we don't cause bugs for customers or otherwise alter the products in ways that degrade retention or activation, we have started to put a lot more of the individual changes present inside of a release behind a feature flag. So, given that, I think it's really, really important to talk about why it's better to control the release through these flags instead of through configs. Configs are usually things that live as code. Think Terraform or Pulumi scripts, YAML files that live inside of your code base. Whenever you want to change a config, you actually have to make that change inside of the YAML file. Then you have to commit it. You have to open a pull request, get the pull request approved, wait for CI to run on it as well, merge the pull request, and then wait for CD to actually deploy it. That's a lot of lag. Whenever something goes wrong, if you're reliant on a config to fix it, then most teams are probably going to have at minimum 30-minute delay to get the new config deployed. In contrast to that, if you control your feature operations with flags, then they become instantaneously live at the same time as your code deploys. So if something goes wrong, you just flip the flag and you're safe, it's off. If something goes right and you want to roll out the release to more of your customer base, you just increase the percentage of the constraint and it starts to roll out further, all without you having to wait on that slow config file change process where you have to open and merge a pull request. And this has been really, really critical for our team. I think that the confidence that we can have baking in more changes to every release has dramatically improved as we started making use of more and more feature flags. Another thing, um, last week I was considering whether we should have our AI agent panel, if you use Cursor, it's a similar thing for that, but inside of our WYSIWYG editor, be on the left or right side of our what you see is what you get editor. It's a bike shed problem. A lot of people in the company want it on the left. Some people want it on the right. Some customers want the left. Some customers want the right. Uh, and instead of bike shedding it internally and burning a bunch of time, I figured let's just put up an A/B test. So in this case, I did not actually build the test. I used Claude Code to build the feature. Then I also used Claude Code to create the flag for the test. I told it, set up the A/B test. And then, inside the context, I've written a skill where it's able to learn about how it can use Unleash. And then I have an Unleash API key for the development environment that we use present inside of my bash RC file as well. So Claude Code was able to actually use that API key I have along with the Unleash admin API to create the agent panel right flag. And then I set up a 50-50 gradual rollout sticky on our organization IDs. So basically, everyone in a company will see the agent panel on the same side, meaning you won't have one person in your organization on the left and one person on the right. I then wired that flag through our Next.js app, or well, Claude wired the flag to the Next.js app. And then Claude also attached the assignment to analytics within our post hog dashboard. So every event carries which side a customer is currently using. Then we tested that in development, copied and pasted over to production, and that was it. We're all good. The agent was able to do all of the plumbing, and then all I had to do as a human was pull the lever to roll out to production. And I thought this was incredibly cool. The fact that Unleash is so API first makes it an extremely usable product for coding agents. So you don't have to click around the dashboard yourself manually all the time. You are able to offload a lot of the setup process to Claude Code or Codex. And I recommend doing it. And then you can see that after we flipped it, within 48 hours, we had a near perfect 50-50 split of users between the left and right side panels. This used to take a week of experimentation infrastructure, rolling it ourselves every time, but now it's just an hour of me going back and forth with Claude. And it isn't one-off. We build and create different kinds of tests using feature flags with coding agents all the time. And experimentation for us has gone from one-time or two-time bespoke events to everything that we ship almost. And I'm excited to figure out whether left or right is better and archive that flag soon. Yeah, so my overall takeaway here is that feature flags are the interface between AI speed and human judgment. You can use agents to create flags, create code, and propose rollout strategies, and then you as the human own the exposure decisions. I like to say merge at AI speed, release at human speed. Uh, Given that Unleash is API first, agents can drive it like any other tool. Environments, gradual rollouts, and stickiness. It is one control plane that's accessible to both humans and AI. And we think that's very powerful for our team at Mintlify. Other thing, just circling back here, is that we started out using Unleash in October with the front end, but we eventually realized a few months later that the back end needed it too. And I think that for a lot of teams, it's an observation that you will make after beginning to use a feature flag tool. Make sure that you use it for both the front end and the back end. It's useful in both places. If I had to put this into a list, what you want to do is build levers as feature flags before you need them, create standing kill switches for every risky feature that you're going to have. And if you have anywhere inside of an incident runbook that says redeploy, you know that you're just one bad night away from click opsing your infrastructure. Get rid of everywhere that a redeploy is required and switch to a feature flag. Second, you want to make flags the default instead of the exception. Work with your team to put gradual rollouts on everything and archive your unused flags aggressively. You want to see that your flag count is both going up and down to know that you have a healthy feature ops team. Finally, give your AI agents the Unleash API instead of, and give it the Unleash API for the development environment instead of production. Let the AI agents build the entire experiments and then keep the rollout and on switch and archiving of them human decisions. We've had a lot of success doing that, and I suspect that you will too. That's everything from me. Thank you so much. If you are looking for my socials, you can look me up on LinkedIn. Uh, I'm Nicholas Khami over there. And then on Twitter, I am at Skeptrune, SKEPTRUNE. Again, thank you so much. Cheers.